Okay, there we go. So, the essence of software development. There we go. Oh, hang on, I'm just going to change it so it's, I can see the whole thing. Sorry about this. Okay. As we talked about last week, software development is hard and unpredictable. How many of you have experienced that? Yeah. There's nothing wrong with you. It is essentially hard and unpredictable. This is why I have been forever skeptical. How many of you have seen the article saying, well, you know, it's a dying, software engineering is a dying thing. AI is going to replace all of it. I've been seeing that for 40 years, literally. There's a program that came out, I want to say in the late 70s, called The Last One. This was a program that would run on your PC and could be used as a program generator for any program you wanted to write. And of course, it died very quickly. Most of software work is intellectual. It's not clerical. And as we talked about last week, a lot of it is discovery. It is invention. It's not merely pathfinding or solution finding. It's coming up with the insight to say, how about if we do this? How do people like this? Awful lot of it. How many of you have done UI, UX stuff? How picky are users about the user interface? Okay. I posted, I mentioned I have a daughter who's a software engineer. And I posted a little meme on her Facebook page a week or two ago that said, me graduating with my BS in computer science. I've studied machine learning, you know, analytical geometry, so on and so forth and so on. Me at work, I just spent 2 hours trying to center a button on the screen. You know, having done a word processor, let me tell you, one of our biggest constraints is that people will not tolerate too long a delay between when they hit the key and when that letter appears on the screen. And we had to do a lot of work in fine-tuning, performance tuning, to make sure that there was no perceptible delay as people typed. Huh? Yeah. So, because it's hard, software specification and estimation is hard. I have several books on software estimation, and yet estimation fails time and again. Robert Glass, if you're going to read anything for extra credit, I would strongly recommend Robert Glass, Facts and Fallacies of Software Engineering. I actually used to have that as one of the 3 books. But I switched over to Accelerate because I wanted to get some of the modern IT practices in here. But he makes this comment, estimation is usually done at the wrong time, start of the project. You're kind of like, well, that's when you want to do it. Your requirements are vague at best. Furthermore, as I note further down here, how many of you have noticed when you go from, you do requirements for a project, then you start to do design and implementation, what happens to requirements? Boom! They explode. Because you're suddenly having to answer dozens and dozens of smaller questions and issues. What's our decision? How are we going to do this? What's actually required? So, estimation is usually done at the start of the project before we actually have, literally before we can have, a sufficiently complete specification. And it's usually done by the wrong people. It's done by managers, not people doing the writing.
And sometimes, I was just going to say, sometimes clients, I guess they don't know what they want.
Oh, yes.
Until they see what you built something, they're like, oh, so I can do this and this and that. I guess you can.
And that actually is very critical, yes. Again, how many of you have had the experience of showing something to a client, and the client says, oh, no, that's not really what I wanted. Anyone want to tell a few, you know, a good horror story you want to share on having to do that? I mean, The issue is general. Clients don't know what they want until you show it to them. This was actually one of the biggest driving factors behind the evolution of Agile methodology, extreme programming manifesto. Yeah.
I was just going to say that sometimes they know what they want, but then they see it and they want to add more to it
Yep.
as well.
Or they say, I don't like it.
That's them.
That doesn't look the way I thought it looked in my head. It's like, well, this is what you wanted.
Yeah, there's projects that have built where they end up not getting used at all eventually.
And I've actually, in cases that I've worked on project failure where disputes have arisen, there have been end users who have said, it's a typical re-engineering project. You've got some old legacy system and someone's coming in new, either with customizing off-the-shelf software or doing a from-scratch development. And the end users say, we want it to work just like the old system, but better. Literally. I've literally heard that phrase in 2 different projects. And end users can have a lot of power. End users can, in some cases, sink projects. No, we just don't accept this. I'll have more to say about that. One of my other favorite maxims, SpinRad, this is actually out of Reckton and Meyer, Art of Systems Architecting. I will probably, there's a great appendix there, which are heuristics for architecting. I will probably scan that and post that as a document you can look at and use. It'll be very useful in the midterm. In creating a new software program, all the important mistakes are made the first day. That, I can't tell, I've used this in court. It's kind of like from day one, the fact that they were going forward and the assumptions they had, it was wrong. It was almost doomed to fail from day one. This happens on a lot of projects. You have, you're making decisions. Oh yes, of course we're going to re-engineer this, and we're going to do it using X, and we're going to do Y, and so on. No one said, wait a second, that's not going to work for these reasons. They just sort of launch in and dig the hole deeper and deeper. People matter most. I'm going to say that over and over and over again in this class. I don't care. You can pick any tools. You can pick any methodology you want. If you have excellent people, they can bring the project in successfully. Likewise, you can pick any tools you want, any methodology you want. If you have the wrong set of people, they're going to fail. The methodology will not help them succeed. Well, it may help them succeed in theory, but it is the quality of the people and their ability to work as a team. And we're going to talk a lot about teams next week because that's your project organization lecture. It is the quality of the people that determines the success more than anything. Process or methodology, I used to have an argument. Carol Teasley, one of the best people I ever worked for, if she called me up and said, hey Bruce, want to come work for me? I'd go work for her again. She was vice president at Fannie Mae when I was there, managing about 25 engineers there for 2 years. And she and I used to have this argument back and forth about process and methodology. And her argument is, the process or methodology, they're all worthless. Or they really don't matter because projects fail regardless of the methodology. And my argument was, no, it's that people just don't implement them right. Well, 25 years later, I'm actually more on her side. It's really getting off on the right foot, having the right people, creating the conditions of success, and you can do as pure waterfall as you want, and if you've got the right people, it'll succeed. You can have the absolute best Scrum Master and everything else, and if you have the wrong people, the project will fail. SQA. You're going to hear me talk a lot about software quality assurance. It is the red-headed stepchild of IT. I can say that because I have a red-headed stepchild. It is badly, badly neglected. It is underfunded. It is underappreciated. It is always the first thing to cut. And as we'll see in probably next week's readings in Brooks' Mythical Man-Month, his rule of thumb estimation is you're going to spend 50% of your time finding and fixing bugs. And that's actually just about true. The problem is we never plan for 50% of our time testing. It's more like at Pages, when we closed on our venture funding and we hired full-time CEO Larry Spellhog, I had a lot of respect for him. I liked him, liked working with him. But I wanted to hire a director of quality, and Larry, bless his heart, said, why do we need a QA department? Can't we just hire some college students to type on it a bunch for 3 weeks when we're ready to ship? I said, no, Larry, that won't work. Luckily, I won that one, and we did hire a director of quality and actual full-time quality engineers and so on. But there is that mindset. Testing always comes last. One of the important things we'll talk about how to accelerate is the rise of automated testing. But automated testing is not a panacea because, as one of my students last semester said, last winter, he said, we have automated testing, but we have a really lousy test suite. So yeah, we test automatically, and we run through all our tests, we can pass them all, but it's a bad test suite, and we let bugs through all the time. So you'll hear me rant a lot about SQA. Be on the lookout for organizational dysfunctions. We'll talk a lot about that. That'll come up particularly out of the readings in Peopleware, Mythical Man-Month, or no, Peopleware and Accelerate. Now, what are your reactions to this? Anything you want to add here, or any specific comments or questions you have on this list? Yes?
My brother works at Microsoft, and they don't do QA because engineers do QA, and he says it's a huge nightmare.
Yeah.
Just no one does it.
And this is actually a constant battle. Do engineers simply throw it over the transom? Because what you have there is you have engineers who will check and craft and throw it over, hoping that QA catches their errors. When QA catches, they're like, okay, I'll fix this as this. I'll throw it back over and let them find my bugs. So yes, I think I'm a firm believer in automated test suites and having developers do QA, but not having a QA department, I don't agree with. Yes?
On that same vein, my company that I'm in with right now is just barely starting up. My current boss went to his boss and had said, hey, why don't we have a QA department? And they're like, don't feel like it's important. Don't feel like we need to actually test these things all that much. And so he kept pushing the point and said, all right, why don't you do it? And so he just on his own was the entire QA department for the company for a year.
Yeah. Yes.
So I interned at Pluralsight this summer, and they don't have a QA department, but what they have, it's not because they don't value quality, it's because their method for having quality software is to do pair and mob programming, and so you have checks on programmers that way, and you go slower and you catch bugs. And they truly, actually do test-driven development. And so it's built into their practices, and they're accountable to that test-driven development because they code together. And so I think, I'm not an expert here, but I think that that's how they assured quality without a quality assurance department, is that they had other practices that they implemented very intentionally to have quality.
Yeah, and if you implement those well, you will achieve quality. Pair-driven, pair and mob programming, there are debates back and forth on that, and it depends on, you're back to the cultural environment and how it's being used. We'll see later on that good source code inspection will eliminate 90% of bugs ahead of time. And my favorite, with all my years of programming, my favorite test tool is to drag someone else into my office and say, I have this bug. Let me describe this bug I'm dealing with I can't fix. And I'll start to explain it, and I'll get halfway through and say, never mind. I just figured it out. Seriously. And pair and mob programming and source code reviews are designed to do that up front. So yes, but on the other hand, I've gone in, you'll hear me talk about this project. I was brought in, I led a team of reviewers on a project that was supposed to take 2 years and 180 million. When they brought me in, it had been going for 4 years. They had spent $500 million, and they had zero code ready for production. And the question I asked is, what do we need to do to get production? My first 2 questions is, who's the chief architect and who's head of quality assurance? And there was no one for either one. And I'll talk more about this project later. But that was the case, and we did 3 months of inspection, component by component, and found big gaping holes, big massive gaping holes in terms of any sort of test quality assurance, verification against requirements, and so on. And they didn't like my answers. Any other comments? Yes?
I was just going to say, Microsoft can get away with not having a QA department because their main customers aren't like normal users, they're businesses. So they push all the updates out to normal users first, and then a few months later they push it out to businesses.
It is a standard business practice, and what I find it fascinating, this has actually become entrenched, particularly in the gaming arena. I'm going to do early access games on like Steam or Epic or whatever. We're going to push it out to you and have you find all our bugs. That's actually a very common practice in the software industry. We're going to use our potential or existing user base as our QA department. What's very interesting is the number of games you'll find that have been in open access and pre-release for like 2 or 3 years without actually shipping a 1.0 version. That suggests some of the problems with it. Okay. Yeah, I got it. Okay, why these 3 books? I talked about them. I'm not going to spend a lot of time. These are classics. And they're classics, and they're still in print, and they're still read, and they're still referenced because, frankly, they pretty much capture the core issues in software development. It is a little depressing how much of what Brooks wrote in the first edition back in 1975 is still the root cause of billions of dollars in software failures today. We know what the root causes are. People keep thinking, oh no, it won't apply to this project. We're using tool X, we're using methodology Y. You know, we have strong, clear intent among our programmers. Accelerate, I adopted starting a year ago because it's actual research-based findings on what separates high-performance development environments from low-performance ones. And so it's not. This is something Robert Glass complains about in Facts and Fallacy. He says a lot of conventional wisdom in software engineering is based on wishful thinking and, oh, that's a good idea, and oh, this makes sense. It's not based on actual research. Does this work or does this not work? The Accelerate spent 4 years doing annual surveys of organizations and correlating what their practices and so on were versus how they were actually performing. I'm not offended, just so you know.
I'll talk to you after.
Okay, Mythical Man-Month, Chapter 1, The Tar Pit, which itself is a pretty telling title for, and again, Fred Brooks was man in charge of doing the OS 360 for the IBM 360 mainframes, which was my first computer I programmed on as a first-year computer science student here at BYU. And it was late and over budget, but it was an extremely successful product for IBM. But he basically sat down and wrote up and said, okay, here are all the things that went wrong and why. He has an interesting 3x3, and this is very useful. He says, you know, most of us talk about programs. Well, it's so hard about writing a program. Well, and this is what he calls a program. How many of you have written a program for yourself, like on your own computer? Okay? Or even just a program that you wrote on your own for a class. I assume all of you have done that by this point. He says this is sort of, we'll call this difficulty 1. He says, then, and I'm going to update his terminology a little, you have a commercial program, which is a program that is for use by others, that you're going to somehow sell or deliver or whatever. How many of you have been involved in writing code that actually other people have put into production? Okay. How much harder is it than writing just a program for yourself? What makes it harder? What are the things that you find yourself having to deal with? Yeah.
A lot of the times, especially if you're writing this for a business, you've got to work with all the different stuff they have. Like, if you're building a display that displays the schedule, you have to get it to work with all the different scheduling systems out there instead of just yours.
Yep.
I find it depends a lot on whether it's being used internally or externally.
Yes.
So
Yes, it
it's much
does.
easier to do internal than external.
And what happens if you have to use it externally?
Then it becomes like, there's like a million more steps that you need to do to make sure it's a quality product.
Yeah. Yes.
You have to check a lot more corner cases because you don't know how everyone else is going to use it.
Yes, users are idiots, yes.
When they want a very particular look and feel, something can be extraordinarily more difficult than something else that's also good to implement because that's what they want.
That is a critical issue. There is an aesthetic quality to software that can be a tremendous time sink. It's kind of, oh, that's not quite the right shade of blue. And I want it to sort of fade from the upper left corner to the bottom right. Yes?
Security.
Security, oh man. And security, I'm sorry to say, is even more of an afterthought these days as quality assurance. I had a friend, I posted an article on Facebook about someone who found they still had access to their IoT light bulbs in a house that they had moved out of. They could control the light bulbs from their new house. And one of my friends posted back and said, yeah, I said, I can still see 2 power controllers in a house that I've been gone from for 2 years. IoT, Internet of Things. Security is just atrocious. But security in general is atrocious. Yes, I know you have your hand up.
It was a similar bit of comment before, just UX is going to be a lot more work because I have a pretty good, not a perfect idea, but a pretty good idea of how I want it to work and the feel I want it to have. I've got no clue what they want.
Yeah, and they'll tweak it endlessly. Yes.
Style guides. So like style guides. So
Oh, yeah.
the different styles of how they want the code written, the certain processes you're supposed to follow, and the people who get really upset if you don't.
Yep. Yes.
Accessibility.
Accessibility, yeah, which is a big issue. Making sure your software is accessible, that adheres to whatever the operating system guidelines are and whatever you have to provide. So, and he gives us a factor of 3, but as we noted, it can actually be more than that, particularly, internal distribution tends to be easier, meaning you can make the end users live with it more. Whereas external distribution, if people don't buy it, you're in big trouble. He then talks about, I forget the phrase he used. What was it? Programming system. Yes, thank you. I guess I can look up the slide. And he's talking about something you use to write code or that you write code on. So we're talking operating systems, compilers, software tools, and so on. Now, he gives us a factor of 3. If this is simply being used by yourself or for internal purposes, how many of your software tools for yourself? You can be kind of sloppy with it if it's software tools for yourself, can't you? I've done this from time to time in cases where I've had to do analysis of source code, and I'll sit and write a program to do a particular type of analysis, and I'll sit and modify it again and again. Say, okay, I want to look at this. And I'm not preserving stuff, and I'm not, and I know there are places where it'll blow up, and I just don't do those things. So it's much simpler. And then, commercial programming systems. Gives us a factor of 9. This is where you're writing an operating system, language environment, IDE, software tools, which you intend to sell. And this was his experience because he's doing the operating system with all the development tools associated with it. Have any of you ever worked on anything like this? I have, but only, oh yeah, we'll check.
Yeah, we've done one.
Huh?
What was your question?
Have any of you ever worked on something like
yeah.
this?
With Domo and their operating
Okay,
system.
with Domo and their stuff, yes. Back 30 years ago, I did some of the user guide and technical manuals for a company called Borland that was making software tools. Borland Pascal, Turbo Pascal, Turbo C, Turbo Pascal for the Macintosh. I'm especially proud of Turbo Pascal on the Macintosh because I wrote a tutorial section on how to write a Macintosh program where you did not have to use Inside Macintosh. Most of you are not old enough to appreciate that, but that was one of my great technical writing achievements. But Philippe Kahn, who is the founder of Borland, told me on more than one occasion, he says, never go into the software tools business. He says, your users are absolutely unforgiving. And that's true. How would you feel if you found an error in a compiler? And I found an error in a compiler. I worked in technical support for development tools at Sun as a contractor for a few months. And there was a bug report that came in on their C compiler for their Sun OS 386. And I picked up the ticket and I was trying to reproduce it using assembly debuggers and so on and looking at the stack. The compiler, this is a C compiler. This is 1989, so it's not like we're talking early days, so to speak. Under a number of circumstances, the C compiler was not properly popping off the stack when you returned from the subroutine call. And you're running with garbage on the stack when you return. And I remember discovering that, and I was just appalled. It's like, how can you put out a compiler that's not doing the simple basic thing of pushing the parameters and then getting everything correctly back off when you're done, so you get the right result if it's a function. I wrote a rather scathing letter when I submitted that to the tools. So, what you're writing is going to have a big impact. Yes?
I'm curious as to when a program becomes a programming system. Because you mentioned writing a little tool for yourself, but I feel like that fits more into the programming region.
It's usually if it's something that's going to help you do something else. In other words, if you're writing a tool that, if you're writing your own IDE, you're writing a library that you're going to use. One could argue, is that a program or is it just a library? But if it's something you're going to write other programs you're going to make use of, you have to be really sure that it's working correctly, because otherwise you're going to corrupt every program that you write with it. Whereas if it's just your program, it's like, oh, those answers don't look right. I'm going to look at my little program. Okay, I've got that corrected. So if I've got a calculation, like a rounding error, let's say, in a subroutine that I have in the library, and I don't know it, every program I write using that library is going to get wrong results. What are some other types of software complexity or some other things that make software difficult to update and retain that you've experienced? Anyone? Yes?
When your program's going to be used to do a lot of different things.
Yeah.
A lot of them might interact. That data could be used by different sections of your program, which can cause all kinds of problems.
Yes?
Keeping legacy sort of functionality. If there's a better way to do it, and you need to change a whole bunch of things in order to do that, but you still have to keep.
We will talk about the nightmare of maintenance. Backwards compatibility. But yes, that's a very real issue. If there's legacy data, legacy functionality, other systems that you have to interact with that were not written to the same standards, the same level of quality, or that are just flaky, and your code has to make use of this somehow and yet come up with the correct answer. Yes?
When you have to work with multiple teams that are working on different parts of a project, or when your program has to interact with some sort of external hardware like a microcontroller that's connected by Wi-Fi or something, that can be really, really irritating to work with.
Yep. Yes, it can. Yes.
Are the deprecated functions?
Yep. It's like, you've got, actually in this trade secret case, part of the reason that the developer, it was a lone developer who'd written about 1 million lines of ASP classic code. And one of the reasons he'd never updated it to ASP.NET or anything more recent than that, and had not updated the, let's see, was it the IIS or the SQL Server? There was a dependency between them. And if he changed one, he had to change the other. And it was going to be a massive amount of work, you know, if you updated the IIS, he's going to have to go back and rewrite all the classic ASP or vice versa. So, yeah. Let's see here. Okay. What attracts you to programming? What do you like most about programming?
Problem solving.
Huh?
Problem solving.
Problem solving. What else? I hope you like programming. You're about to graduate. Do it for a living.
That little high you get when something works.
Yes.
The fact you don't have to deal with things like physics, you can just deal with straight up ideas.
And you know, and Brooks talks about that. He says this is the closest thing to dealing with pure thought stuff, and it really is. He says it's like magic. You do incantations, and it does things in the real world. It's like magic. Yes.
I think being able to have other people be creative and see how that helps them or
Yep.
be excited to use it.
Very much.
Personally, I'm into optimization, just being able to find a more efficient solution than what's already been created.
You'll go far, but remember Don Knuth's dictum: premature optimization is the root of all evil. Yes.
Dissecting very human problems, bringing them down to a mathematical level.
Yep. Yeah.
I think just the sheer possibility of what you can do, it's
Yep.
like limitless.
And here's the advantage you have: the hardware gets better every year. I mean, stop to think. When I did Sundog on the Apple II, we were on an 8-bit integer microprocessor on a system with 64K of RAM and 140K floppy disks, and a like 3-something by 100-something bizarre high-res resolution. The entire game operating system and everything would fit in what occupies the same amount of memory as an icon on the screen nowadays. So yes, you get increasingly fast hardware, increasingly more sophisticated libraries. How many of you use Unity or Unreal or any of the gaming engines, or at least look at them? There's a lot out there, and you just get to do more. Now there are problems with that we'll talk about. The joy, and I have 10, of always learning. I have several kids who work in IT. And what I've told each of them as they've gone into the field is that here is the advantage and the disadvantage. The disadvantage is you're going to be learning for the rest of your life. I'm still learning new stuff. I have to in order to keep up with the cases I work on and so on. The advantage is people pay you to learn this stuff. And you learn it and they give you a raise. So, I have a son who is a system administrator for a company up at Point of the Mountain. He's currently getting his certification with Microsoft Azure. The company is underwriting him both in terms of time and tuition to do this. And as soon as he gets it, he'll get a 10K bump in his salary. That's a pretty good deal, isn't it? So you have to be willing to be always learning. I have a vast library at home. I basically, when I started doing expert witness work, I realized I had to stop throwing away all the manuals because sometimes I had to go back and actually look at MS-DOS or Windows 95 or whatever, and be able to pull up references and see stuff, or document what was or was not available in terms of prior art in a certain time frame. But it's fun. I still like programming. I don't do a lot of it at times because I'm old and lazy. But when I do it, it's the same rush. It's like, hey, it just made this work. I wrote this code. It did what I wanted to. I've got the answers I want. Okay, woes of the craft. You must perform perfectly. That's, the computer does what you tell it to. And sometimes the computer underlying that is even more, the next point, other people set your objectives, provide your resources, and furnish your information. How many of you had the experience of going to use an API for library or utility or whatever, and it just doesn't work the way it's documented? It's supposed to work. Okay. That's frustrating, isn't it? Or you have the actual API functions, you've got, say, half a dozen functions, but what you don't have is documentation telling you about the deep interface, which says, this is the one you have to call first. And based on your results, you either call this one or that one. And based on these results, then you want to do this, and then you need to clean up with this, except in this case, then you need to clean up with this other function. Okay, there are APIs like that. And this is why this is why things like Stack Overflow exist. It's like, how do I make this work? It's learning that second level of magic incantation is often difficult. And trust me, back pre-internet days, when I was coding, you would scrounge. Well, it wasn't pre-internet, but pre-web, so on and so forth. You would scrounge to find examples of working code. They were like gold. If you were dealing with an API, it's like, how do I get this to work? And you dig, and you'd ask people, and someone would send you a file, and it was working code. It's like, okay, this works, and I can prove this works. Now I'm going to start doing piecemeal changes to try and evolve it towards what I need to do. And if it stops working, then I'm going to have to back up and figure out what I did wrong. And you often depend on other people's programs, which are less than perfect. This will be something you'll hear me say multiple times. The quality of a complex system is bounded by the lowest quality of any given component. Now, that's not quite exactly true, because if you have a low quality component that's rarely used or has little impact, then no, it's not quite the same. But generally speaking, it is true. And this is actually another reason why AI programming remains dubious, in my opinion. Because it's usually pulling components and trying to put them together. You have to have good stuff to start with, and then you have to have the insight to know how to put them together. How many of you had the experience of getting a program to about 80 or 90% completion and then taking days or weeks to try and get it to work perfectly? Okay. Next point. Designing grand concepts is fun. Finding needing little bugs is hard work. It can just drag out. This is armor. This is sort of like, well, you know, I got it 80 to 90% there, and I keep doing stuff, and stuff keeps blowing up. But the answers aren't quite right. Debugging does not go as fast as you think. We keep thinking debugging is going to look like this. You know, we're going to get here, and suddenly it's all going to collapse. Instead, what debugging tends to look like is more like this, where you're never quite sure if your number of open bugs is ever going to hit 0 here. And what you do in the real world is you basically say, oh, we're going to defer all those bugs, we're going to ship anyway. We'll talk more about that. And of course, the problem is the product is often obsolete before it's complete. What's been your experience? What are the things that you have found painful about software development, either here in school or in internships or jobs that you've had? Anything we haven't talked about? Yeah.
Constantly, if you're working on production level stuff, you're constantly going back to old code that you thought was done, you thought was all good, and you're
But
back.
you have to go back and do more stuff. Yes.
The IDE keeps throwing the top of you.
Here, let me do this for you. Ashton's law. Alan Ashton. How many of you know who Alan Ashton is? He was my first computer science professor. He taught my very first class, and taught my last class, which was operating systems implementation. But in that very first class, he said something which I have quoted ever since as Ashton's law. He says, whenever people try to do something for you, they usually end up doing it to you. He's talking specifically about software. And it's the same thing. It's like, oh, here, let me help. He's like, no, I didn't want that. Don't do that. Let's see, there's a hand there.
So one thing I run into a lot is when you're trying to use like frameworks, like a web framework example, and there's a limbo in versions. Like the version you're trying to develop something for is probably going to be outdated soon, and the new version that's coming in is like, do I develop for this beta version that has lots of bugs, or do I build it with the new one knowing that then I'll have to refactor lots of things once the new version comes out?
Yep. Oh yeah. that's back to the product is often obsolete before it's complete. It's kind of like, I'm developing for this. Oh, we have a new, better version, and everyone's using this, and now I've got to go rewrite all my code. Yeah.
I work on Learning Suite, and one of the things that was really frustrating is there's specific professors, just one or two, that like need one specific part of Learning Suite that would be so easy to just dump otherwise. It's like, no, we can't do that, otherwise Debbie would be mad.
Yeah.
And it's incredibly frustrating.
And that's more real, particularly if you're doing internal software. That's a far more real. You can sort of get away with it with commercial software. It's kind of like, oh, you have to adhere with what we're willing to ship. But if you're doing in-house software, corporate software, whatever, you'll run. This is back to the tyranny of the end users. Yes?
I was just going to say similar to the different versions, but with your own code where you do this thing that you have to figure out how to do, and by the time you're almost done, you figure out a better way to do it. And then how much are you going to have to refactor to make it consistent versus like, oh, we'll just deal with it because it works, it's just inefficient. And, you know.
True story. My first programming job, which I started the same semester I started my computer science degree, was with the Translation Sciences Institute here on campus doing computer-assisted translation. It was based on a theory called junction grammar by Dr. Ellen Lytle from the linguistics department here. And here was the problem we kept facing. We would work on it for 12 to 18 months, get really close to what we thought was actually a good first cut of the software. And Dr. Lytle, bless his heart, I took 2 classes from him, I have high respect for him, but Dr. Lytle would come back and say, I've been rethinking and I've changed these things in junction grammar. And we'd have to go back and do recode all the way through for this new aspects or this changes to theory. We went through that, I think, 3 times, at least twice, maybe 3 times in the 4 years I worked on the project. Yeah.
So part of this looking for bugs when you're searching on Stack Overflow, wanting to find stuff. The fun part is finding, not only knowing what to search on Stack Overflow, but searching through all those slightly not quite what you want answers to find that one that
the one that perfectly fits your situation. Yes. Yes, I've seen that more than once. Yeah.
I think like a major woe, in my opinion, is when you find the answer on Stack Overflow and they say, yeah, I just uninstalled it and reinstalled it and it works. And you do it and it does work, but like that's not a fulfilling
well, what's wrong?
answer.
Why didn't it work in the first place?
Yeah.
Yes. That, I mean, that's again, a classic meme which has been around for a long time. Shows someone in front of a terminal. It's like, my program's not working, I don't know why. Then the picture below shows the exact same picture. It says, my program is working and I don't know why. It's true, and it's scary. It's like, why did this suddenly start working? I don't know what changed. Yes?
And you have the Stack Overflow answer, and it's just never mind, I fixed it.
Oh, yes.
Oh, working on other people's code.
Oh, yes. We'll talk about that a lot. We will talk.
My own past.
I won't. Yeah. I won't dig into that now because that will be a discussion. Okay. Peopleware. We're going to finish up this pretty quick, and then after the top of the hour, once everyone else is back in class, we'll do a biology break and come back with other projects. Peopleware, Chapter 1. By the way, the chapters in Peopleware are short. They're very readable, large print, big margins. So don't get scared if it's like, I've read sections 3 and 4. It's like, yeah, it's going to take you about 30 minutes. Chapter 1. This was their finding, which of course jives with everything else, is that it's not technology that kills projects. It's sociology. You can almost always trace the fundamental roots of project failure back to human decisions. I don't know if I mentioned, I testified before Congress 3 times. We'll talk sometime as how that happens. DC is a bizarre place. I went out to manage some consultants, and by the time I left, I had testified 3 times before Congress. I'd given a keynote address at the World Bank. It's just sort of, it's a weird place, okay? It just shows any damn fool can testify before Congress because, hey, I did. But one of the things I talked about, talking about project failure, I said, indeed, when wondering why so many projects fail in spite of all that we know, one could simply cite the 7 deadly sins: pride, envy, greed, sloth, lust, anger, gluttony. Said it's as good an answer as any and better than most. It almost always comes down to human factors. And that's going to be a major theme through all of Peopleware. It's not that the technology, leapt up and bit you in the butt. Occasionally you'll have projects where you really are trying to do something that's impossible, but in most cases, we're back to all the important mistakes are made the first day. We're going to do this. It's like, should we? Can we? Will we? Those are the questions you want to ask right off the bat. Oh, you're being so negative. And here's the third point. It's real critical here. Most managers are willing to concede that they've got more people worries than technical worries, but they seldom manage that way. Why? Because it's hard. It's easier to come up with spreadsheets and flow charts and schedules and PERT, you're going to do PERT Gantt charts and so on and so forth, and these can be useful tools. But, as I suspect most of you will discover in the course of this semester, and most of you have done group projects at 340, whatever, that the real stumbling blocks tend to be people not carrying their weight. It's sort of the, what are people actually doing? Any observations, feedback on this? Everyone's like, yeah, let's get through the slides. Okay, get through the slides. Accelerate, and you only had chapter 1 here. And this is mostly just organization. They're talking about that there are 5 areas they're going to focus on, which are continuous delivery. This gets back to CI/CD, automated testing, so on and so forth. Architecture, products and process, lean management, and cultural changes. And I'll talk about cultural. There's a chart we'll bring up later, one of the later lectures, that has 3 general categories they give on cultural types, which is actually a very good chart. It's very important, and it's very useful when you start interviewing and looking at companies. They push DevOps, but it's not a silver bullet. I have a son-in-law who is extremely skilled at DevOps, doing software development, leading teams down in San Diego, and he's the first to say, no, it's not a silver bullet. Any more than, say, doing Agile is a silver bullet. You still have to have the right management support, you have to have the right people on the team, and you've got to get things done. Okay. What you need to do, and we're going to take as soon as we're done with this, we will take a 10-minute break. Though if you can come back quicker, we may get started sooner. We will do all the project voting and project assignment and so on after the break. So for this week, you need to edit your team's project page on GitHub, list all the team members there, and that's really about all you need to do for this week. Listen to at least one podcast this week. The podcasts are on the website. You can go down, look at the topics, pick one to listen to. As I said, before you start listening, check to see how long it is. Pretty long. You may not want to spend that much time. For next week, what we're going to talk about is defining your team's organizational goals. In other words, your deliverable that will be due a week from Saturday will be your org chart for your team, as well as a brief document describing what each of those roles is responsible for. This is not cast in stone. In fact, it probably should be. You're going to change through the course of your project based on what your demands are at any given time and what people actually decide, well, no, I'm not this good at it, or yeah, I'll step up and take that, or hey, we didn't realize we needed a DB architect. Readings for next week are still pretty short, chapter 3 of Mythical Man-Month, and these are all updated in the class calendar on the website. I added chapters 21 and 22, which are the first 2 chapters in Peopleware that talk about teams. So chapters 2 and 3 and 21 and 22, and I took them out where they were later. And accelerate chapter 7. So that's, and that's all that stuff is up on the website calendar. So with that, let's take a break till 10 after, then we'll come back and do all the voting for projects and team sign-ups.